Lesson 19.5, Task 4. Use quadratic regression to find a model. Remember, a model is just an equation for a set of data. A scatter plot of real-world data may have a shape that is only approximately parabolic. You can perform quadratic regression on a graphing calculator to find the quadratic function that best fits the data. The calculator may also give a statistic called the coefficient of determination, which is a value from 0 to 1 that is denoted by r squared, and that tells you how well the function fits the data. The closer r squared is to 1, the better the fit. So we're talking about like a scatter plot, and on the scatter plot, the closer the points are to 1, sometimes -1, the closer it is to represent that model. Well, R2 is similar to that. It's called the coefficient of determination. And again, we'll see how to do that using your calculator. And that's kind of a way of looking at the points to see if the data is a good fit or not. All right, so the table shows the speed of a car over time. Use regression to find a function that fits the data, then predict the speed of the car after 11 seconds. So it says the speed of a car is measured every 2 seconds as it accelerates from rest on a test track. All right, so here's our table of values. So let's turn on our calculator. Let's clear out what we have. So we're going to go second plus, and I'm going to hit clear all list, and that's going to clear what I had from before. If you want to clear your entire calculator, you can do second plus 7 is reset. 1, clear all RAM, and then hit 2, or hit number 1. Hit 2, and you're going to reset your data. All right, so that clears everything out. That clears the tables out. That turns off the stat plot. Anything that you have turned on, you can do that. All right, so above here it talked about the r squared. In order to see an r squared, when we write an equation, you have to turn that on. So go to second catalog, and you got to scroll all the way down to where it says diagnostic on. And you want to turn this on. Here it has diagnostics off and diagnostics on. When you hit diagnostics on, and you have to hit enter to actually turn it on, it'll say done. Then that's going to show up the r squared a little bit later when we graph. Okay, if this is not turned on, you're not going to see the r squared when we enter the data. All right, so go to stat and hit edit, and we're going to put our points in. So we're going to start with our x's. So 2, 4, 6, 8, 10. Always look and make sure that those are what you wanted in there. If you enter the points wrong, then it's not going to give you a correct equation. If you need to pause the video and enter these in your calculator, practicing this on your own would be a good thing to do. That way it'll help you remember the steps in order to do this later. All right, so now that we have this in here, we can again look at these numbers and determine that these numbers are bigger than 10, and our normal window is 10 by 10. And we'll also have to turn our stat plot back on. So let's go to second Y. That gives us our stat plot because it's in blue. So that means you have to do second first, second stat plot. And then I'm going to turn my stat plot on. I'm going to hit enter, turn it on. It already has it for the dots here. It's already pulling from L1 and L2. So I just hit enter. And then if I go back to graph, I have to change my window to represent my Y's going up past 79. Since this is not, there's no points below 10, and this is only a 10 by 10 window, that's why you're not seeing anything. So again, I don't have to change my whole window. You can if you want. We don't really need negative x's. You have to have a negative number there, but we can change that to -2. Let's change our maximum x to 12 just because it is at 10, so it's going to put the last one right on that, but if we change it to 12, that gives us a little space there. We'll leave it as a scale of 1 because that's not very much to look at. And then our y minimum, we don't need negative y's either, but you do have to have a negative number there. But our y maximum, we need it to go up past 79. So let's take it up to about 85, I guess. Let's change our scale to, let's go by 5s. And then hit enter. And then when we hit graph, it's going to show you that scatter plot. So we just changed the window here because we changed this to -2. That's why you're only seeing barely this and you're barely seeing anything down here, because really all of our data points are in quadrant 1. So we're just making the window easier to look at the data that we need. All right, so now that we have done that, let's see what that question asks. I can see that the data are nonlinear because the first difference are not constant. All right, so instead of using the calculator, they were looking at the first and second difference again. And I just went straight to the calculator. All right, so this says enter the data pairs from the table into a graphing calculator to find a quadratic regression model. Okay, so we have the data. Now, how do you find the equation? So we put the points from the table in here. And now we go back to stat. And these are steps that you may want to write down because this is very handy to know. And there's always questions like this on the EOC. So you go over to calculate. And we're looking, you can do a linear regression. It'll write you a linear equation, a quadratic regression, a cubic, a quartic, and several others when you get to that. Right now, we've only looked at linear and quadratic. This one, we have determined that it is a quadratic model. So we're going to hit enter, and it's going to pull from L1 and L2. That's where our points, so that's good. And then if I enter through all this, it will calculate that equation for me. So you can see that it gives me an equation here. All you have to do is take the A, plug it in, take the B, plug it in, take the C, and plug it in. This is your standard quadratic function equation. And then because we turned our diagnostics on, remember we went to second catalog, turned diagnostics on, that's why we have R2. If you don't see the R2, then you need to make sure your diagnostics is on. All right, the R2 is 0.999. That's very close to 1. So that means this model is a good representation of these points. All right, if you want to see that on your calculator, I'm not sure this goes through how to do this, but I'm going to show you. This gives you an equation, and if you want that equation to draw it on your graph, because all we had was scatter plots, here's the steps. So you may want to write these down as well. Click VARs and go down to 5, which is statistics. Go over to equation, and it's going to enter that equation, and I missed a step. So you're going to go to y equals. We want it to graph this equation. So go to y equals, vars, stats, equation, and it will copy that equation into your graphing part of your calculator. So when you hit graph, it will show you what that equation looks like. And you can tell that that looks like that fits those points. You know, those scatter plots, this looks like it's a 0.999. Comparison. So it's a very good model for this set of data. All right, again, you'll go to y equals, go to, y equals, vars, stat, 5, and then equation. And that's what copies it over into that equation for you. All right, so once you have that information and they show you here that they've entered the points, they show you the equation, and they're showing you the R2 of 0.999. It looks like they have a little bit different calculator, but it's going to be the same process. All right, so it says look at the value of R2. Does the coefficient of determination indicate that the function fits the data well? Select the correct number and words to complete the statement. Since R2 is close to 1, the function does fit the data. All right, so if R2 was close to 0, it would be like scattered points all over the place, like it would represent nothing. So it does have to have an R squared close to 1 in order to be a good model. So it says the quadratic function that best models the data is, and what they did was take the A, the B, and the C and plug it into your standard form here. And that's where the f of x, that's where your equation comes from. So if you enter a table of values in your calculator can write an equation for you if you know how to go through the steps to make that happen. So that may be an easier way for you if a system of equations is kind of difficult. All right, so to predict the speed of a car after 11 seconds, all you have to do is substitute 11 in for x and solve the function. All right, so 11 seconds, t is our time. That would go in for x. So substitute x. Make sure you use order of operations, or you type everything in your calculator exactly that way, and it'll show that your answer is approximately 81. So what does this mean? It means the speed of the car after 11 seconds is about 81 miles per hour. So it's going pretty fast after 11 seconds. All right, that's all for task 4. If you have any questions, let me know.